Alright, so the next thing we want to look at is equations and stoichiometry. Stoichiometry is basically calculating amounts that change in a chemical reaction, which will have an equation, so they're tied to each other. And at this stage, I would want to first talk about if the fact that you guys can read equations when you understand what they mean. In terms of, let's say you saw 2SO2 plus O2 making 2SO3. Now when you see an equation like this, you obviously know that you can say that two molecules of SO2 react with one molecule of O2 to make two molecules of SO3. But the reason why we use the idea of moles is because now we can also say this in terms of, okay, you know what, this equation can also mean that 2 moles of SO2 react with 1 mole of O2 to form 2 moles of SO3. And so an equation, like they say, is actually worth 1,000 words. So equation tells us a lot, by the way. I mean, it's like a picture for artists is like an equation for chemists. There's so much information in just one equation. And the most simplest way of reading an equation is that it gives you the mole ratio of the particles involved. So here, the mole ratio of SO2, O2, and SO3 is pretty obvious. That 2 moles of SO2 react with 1 mole of O2 to give you 2 moles of SO3. And why is this important? Because tomorrow I say, hey, I really got 10 moles of SO2. So I might say, okay, so how many moles of SO3 can I make from 10 moles of SO2? You know, I might ask that. Because an equation is an actual ratio, so if 2 moles of SO2, because basically what you're saying is, let's make it more structured. So they've given you SO2 and they want SO3. So SO2 is your known and SO3 is your unknown. And their coefficients in their equation are 2:2. What that means is the ratio is 2 moles is to 2 moles. If the ratio is 2 moles to 2 moles, then 10 moles will be how much? And all you gotta do is cross multiply, and X here will come out to 10 moles. So this might seem very obvious, but here, yes. So 10 moles of SO2 can make 10 moles of SO3. Now I'm going to show you a generic technique that we can use to solve any stoichiometric questions. So first, I understood you guys can read equations and all that stuff. Now I'm going to talk about how to solve any generic equation for moles that involve an unknown and a known in a reaction. So what is this method? Well, it's literally a very simplified 3-step method, because in all questions you are going to have what we call a known quantity, and you're going to be asked to find out something which we call the unknown. So what you need to find out, we call the unknown. What you're given, we call the known. And the stoichiometry we just saw in an equation, it all depends on the ratio of moles between the known and the unknown. That's this ratio part, the stoichiometry part, the ratio between moles and knowns and unknowns. What is also important to realize is that we're never going to be given the moles of the known. So a basic idea would be to basically take the known quantity, okay, and convert into the known moles. That's step number 1. And using the known to unknown ratio, find the moles of the unknown. And once you have the moles of the unknown, convert the unknown to the quantity you need that you've been asked for. Literally 3 steps. That's what it takes. Step number 1 is basically the known, whatever quantity of the known you're given, let's say mass, and later on we'll have volume of gases, we'll also have concentration of solution. What your job in the step 1 is to take the known quantity and convert it into moles. Step number 2 would be to use the known and the unknown's coefficients in the equation in a ratio to find the moles of the unknown. Now you want to find the moles of the unknown, but the moles of the known will come from step number 1. And then in step number 3, you're going to take the unknown's moles, which came from step 2, to convert them into the quantity needed, be it mass, be it volume, be it whatever else that you need. And this general technique can solve any mole reaction questions where there's a reaction taking place. Yeah, so that's the idea, and we can apply that to a question right now, but this is the process. All right, so let's solve this example, worked example 17, from the method I just told you about. So the question is asking us that when calcium carbonate, which is limestone, is heated, it decomposes according to this equation, and carbon dioxide. They want you to find the mass of quicklime, which is calcium oxide, which means my calcium oxide is my unknown. That's what I need to find out. When I've been given a certain mass of limestone, so that is my known, KNOWN. And so that's my data in the question. So like all questions, like I said, there are 3 steps. So what you're going to do first is step number 1. So step number 1 you're going to find the moles of the known. What's your known? Calcium carbonate. First you'll want to find the formula mass of calcium carbonate. Okay, if you notice, the formula mass, or the MR, is 100.1. We don't call it MR, but since you're used to it, I can say it, it doesn't matter. So number of moles is mass over molar mass, and the mass you've given is 500, and the molar mass is 100.1, and this comes out to about 4.995 moles, which is approximately 5 moles, but that's the moles of calcium carbonate. We've done this, how to convert mass into moles, which is mass over molar mass. That's the first step, always is. Then the second step is using the ratio between the unknown and the known, or known and the unknown, whichever one you want to write first. Calcium oxide is the unknown, and calcium carbonate is the known, and the coefficients are 1:1, which means that if this is 4.995, then calcium oxide is also 4.995 moles. And so I have that also, which means that if I now do a third step, which is, now they want the mass of quicklime, which means that I want to first know the MR of calcium oxide, which if you do the math comes out to 56.1. So now what I need is the formula number of moles is mass over molar mass. To solve this, the number of moles of calcium oxide I got from the previous example is, previous step is 4.995. The mass I have to find out, the molar mass is 56.1, and here the value for M comes out to about 280.2 grams, which by the way is your mass of quicklime that 500 grams of limestone will give you. This method will always work for every moles calculation that has a reaction equation involved. You'll have a known, you'll have an unknown, and this is the process. All right? Yeah.